In this lesson, I'm going to go over how to solve very basic logarithmic equations. You're going to see after our next video from notes 45 when we get into more complicated properties of logarithms. Then after that, we'll use those properties to help us solve more complicated logarithmic equations. But in this case, these are all pretty basic. And I'm going to review kind of my two main goals when I'm approaching these types of equations, logarithmic ones. My main goal is to get either one log on one side of the equation or to get one log on each side of the equation. If I can do that, then I'm able to move the either logarithmic equation to an exponential equation, or I can drop the logs. So these first couple are all kind of ready to be moved to a different form, or rewritten, I should say. This is a logarithmic equation, log base 6 of x equals 3. And I'm going to rewrite this as an exponential equation. So 6 to the third power is equal to x. So 6 to the third power equals x. And actually, we can just finish this question. That's 216. Okay? Now, again, some of these will be pretty fast. All right, next one. 2/5 to the third power equals x. So 2/5 to the third power equals x. So x equals 8 over 125. Okay, next one. This one is x to the 7th power equals 128. All right, now I don't have x by itself here, so I'm going to take the 7th root of both sides, and I don't know the 7th root of 128, so I'm going to go ahead and leave it like that. All right, but I think I might actually have 2 to the, let's see, do I have 2 to the 7th in there? I'll come back to that when I'm done. Okay, let's do this one. All right, this one is going to be a little bit different, but it is one log on one side. So 3 to the 17th power equals that argument. So watch how I write it. 3 to the 17th power equals 3 to the power of x. Now this should look familiar from the work we did with solving exponential equations, where we have the same base, right? So they both have that base of 3. So that means 17 and x have to be the same. So x is equal to 17. Okay, let's go to the next one here. I'm going to do this base of 9 to the power of x equals 9. So 9 to the power of x equals 9. And that's really 9 to the first power if there's nothing there. And just like the last one, if the bases are the same, I can drop the bases and set the exponents equal to each other. So x is equal to 1. Okay, next one here. I have 45 to the 0 power equals x. So 45 to the 0 power equals x. Anything to the 0 power is 1, so x is equal to 1. All right, so pretty straightforward here. All right, let's get a little more complicated. This one is a natural log, so I told you guys, remember, there's a little base of e there. So e to the power of x equals 1 over e to the 5th power. So e to the power of x equals 1 over e to the 5th power. Now watch how I rewrite the right side. I'm going to rewrite it as e to the negative 5th power. That's still the same thing as 1 over e to the 5th power. And now they have the same base of e, so I can drop the e's, drop the bases, and write x equals negative. All right, this is the first one that's a little bit different, where we have one log on each side, and they do have the same base of 5. So because they have the same base, these arguments must be equal to each other. So the answer is just going to be x equals 16, because we can drop the logarithms. Okay, same thing here, right? They have a log with the same base, so I'm going to set this argument equal to that argument and drop the log. So x squared plus 4 equals 29. I'm going to go ahead and move that 4 over with subtraction. All right, when I get that, I can get rid of the square by taking the square root of both sides. Hopefully you remember what that means. That means x is equal to negative 5 or x is equal to positive 5. Remember, plus or minus? Now, before you move on, you cannot have a negative value in your argument. You can't take the log of a negative value. So we have to make sure that we get positives here. So if I plug negative 5 back in there, I would square it immediately to get 25, and that's going to be okay. And same with the positive 5. So actually, both of these work. All right, so just be careful that you don't have any extraneous solutions. All right, last one here. They both have the same base, the base of e. So I can set these arguments equal to each other. The negative 11x plus 2 is equal to that quadratic binomial. Now this is a quadratic equation, so I'm going to get everything to one side to set it equal to 0. Move that negative 11x, it becomes positive 11x. Move the 2 over with subtraction, you get 28. So we need factors of 28 that add to 11. I'm going to use 7 and 4. That should work. Set each of those equal to 0, and you get x equals negative 7 or x equals negative 4. Before I move on, right, to say that I'm finished, check to make sure that they become positive values in the arguments. You're immediately multiplying by negative 11, so that would make those positive. And on the other side, you're immediately squaring in that argument, which would make those positive. So both of these are also going to work. All right, let me go back to this one real quick, because I think we can probably it might actually just be 2. All right, so 2 to the 5th power is 32. 2 to the 6th power is 64. So 2 to the 7th power is 128. So that actually is going to be 2. I'm glad I came back for that. All right, I don't think I actually knew that 2 to the 7th power is 128. Well, there you go. Okay, guys, so this is it. Remember, the last one's got a little bit more complicated, moving into some quadratics, so reviewing some factoring. Don't forget, these are pretty basic, but my main goals here are get 1 log on one side. That will allow me to rewrite it as an exponential equation, or get 1 log on each side with the same base, where you can then drop the bases and set the arguments equal to each other. So try both of those in the homework. Good luck.